to write the sine function that has these given characteristics, I'm going to go ahead and kind of look at each one of these and figure out what it tells me about my function. There's a couple things that should jump right out at you right away and give you some values right off the bat. For example, I see that my amplitude is 10, so right away I know that my a value of my function is going to be 10. Also what I can see is this graph has been reflected. That's going to actually tell me the a value not only is 10, but that the a value is negative. A negative a value is what reflects the graph upside down. Okay. One other thing that jumps out at me right away is I see that I have a vertical shift of -4. That tells me the k value, the number at the end of the function. So I'll be subtracting 4 from this function at the end. So there's 3 pieces taken care of right away. All that's left to deal with then is the period and the phase shift. Make sure you find the period first. The period, remember, will help you find the b value, but it's not the b value itself. Instead, just like we've done before, the period, which is 2 pi over 5, is equal to 2 pi divided by whatever the b value is. So I have to do a little cross multiplying to do this, or actually this one's really easy. Since the top already matches up, 2 pi, the bottom has to match up as well. So I know the b value of my function has to be 5. And if it didn't match up, just do some cross multiplying and you'll see the b value is 5. The last part of this then will be dealing with the phase shift. This is going to help us find our h value, the number being added or subtracted inside the parentheses. But remember, the phase shift is not the h value in itself. Instead, we're going to do something like what we just did to find the period. The phase shift is equal to the h value, which I don't know, divided by the b value. Well, good thing we found the period first, because that b value was just 5. So that number gets plugged in down here. So again, doing some cross multiplying, and some of these end up really weird with fractions within fractions, so just be careful when doing the math on it. I get 5 pi is equal to 4h, and then dividing by 4, I get an h value of 5 pi over 4. So now, putting all of this together, I should be able to write the equation of the function. So let's go ahead and start with y equals, or f of x equals, or whatever. So I'll start with f of x equals. First up, I need the a value, which we said is going to be -10 in this case, since it's reflected. We already said it was a sine function. The problem told us it was a sine function. Within the parentheses then, I've got to have the b value times x. So we found our b value to be 5x. My phase shift will come next, and remember that phase shift needs to be the opposite of the direction you want the graph to move. So since my phase shift was positive pi over 4, I have to make sure my function is -5 pi over 4. I need the opposite sign in there. And then notice I use the h value, not the actual phase shift itself. And then finally, to indicate how my graph has been shifted vertically, I need that k value. So I'll finish with a -4. So all of that together should get me the function that I'm looking for. There's definitely a lot to keep in mind, but that's what I need. These are really easy to check too. In fact, I'd recommend you to do this. To check the period, make sure you do 2 pi divided by b. Make sure that comes up, the period they gave you, which it does. And then double check your phase shift value. Remember, the h value divided by the b value, which is right there, needs to come up to be the phase shift. And again, it will, but I would recommend you double check it. So there's one example. We'll take a look at one more, but if you think you got it, this next one is pretty much the same thing. So I notice this time that I'm doing a cosine function that has absolutely no effect on how this works, so we'll do this one very similar to what we just did. Again, I'll start with the easy parts. Since my amplitude's 1, I know that a is equal to 1 in my equation. Also, the graph is not reflected, so I know that a is not only 1, it's a positive 1, since the graph has not been reflected. A vertical shift of 5 is going to mean my k value is 5. I'll have a plus 5 at the end of my function. So the last two parts then are dealing with the period and dealing with the phase shift. Find the period first, or deal with the period first. So 4 pi is not the b value, but it will help you find it. 4 pi over 1 has to be equal to 2 pi over b, because that was our formula for finding period. So doing some cross multiplying, I see that 4 pi times b would have to be equal to 2 pi. The pi's would then cross out, and if I divide both sides by 4, I see the b value is actually 1/2 in this function. Okay, the last part of this then will be working with the phase shift. So the phase shift is -pi over 2, and I note right away that it's going to end up being plus in my function. That's how the phase shift works. It's the opposite of what you see in the function. So the phase shift itself is not the h value, but it helps me find it. So I'll begin with pi over 2. and then the phase shift is equal to the h value, which I don't know, divided by the b value, which we just found out to be 1/2 from working with the period. So that's where that comes from. So here's the fraction within a fraction I talked about. It's nothing too bad. I'll cross multiply, so I get 1/2 pi is equal to 2 times h. And if I divide both sides by 2, 1/2 divided by 2 is actually 1/4. So I'll just write that as pi over 4 instead of 1/4 times pi. It's the same thing though. So there's all the pieces I need. Putting these together to write my function then, I'll have f of x equal to +1 from my amplitude times the cosine of my b value we said was 1/2 x. I'll need to do plus for my phase shift because I want to end up actually shifting negative, so I need the opposite sign in here. The h value is pi over 4. And then finally, to get that vertical shift we want, I'll have a +5 at the end of my function. So I can check this one the same way we talked about in the last part of the video, but there will be our function that has all those given characteristics.